teaching performing arts classes have extended lunch. And good luck to the swim team at Clearville Boys.
Still says waiting. All right, so we'll use this side to find the name. This side's a little bit trickier, but most kids find it easier because they're kind of used to the process. Let me get this going. All right. A little frazzled, but we'll be all right. So I don't know if I have the lab book cut out anywhere. Okay, let me cut a piece of it from, give me 30 seconds. Yeah, I guess. But it has to be, yeah, it can't be on my account. It'll just say, yeah.
Is there a time limit?
I don't know. That really bugs me.
Mine's still your iPad.
Yeah, but you.
And this.
Yep, there's two of them in with Derek that I've unlocked and have Zoom on there.
And I would just log into my school account on Zoom.
Yep. Good luck.
Every time I Zoom, I just use my own personal. But the school would have a time limit.
The school one does not, yeah. All right, so here we go. Everyone with me on number one, CAO. Sorry, I've been not prepared. So please, if you would, look at the inside. You see this right here that says start? Yes. All right, well, that's where we're going to start. So please do yourself a favor. Look at the screen for a minute. The computer won't print in the middle, so make sure you connect these arrows over because sometimes that confuses kids. They don't think there's a yes. Okay, so connect those, and then we'll be off to the races. The ones that are in red right here. All right. So, good. I feel great. We have CAO. So that's what we're talking about here. CA, oh gosh. No technology wants to work today. I'll teach from right here. CAO. Okay. Does this compound contain more than one type of atom? Yes, it has two, in fact, Ca and O. Does it have metallic and non-metallic atoms? Yes, good answer. Calcium's a metal, oxygen's a non-metal. So we come down. This question confuses kids, so focus for a second. Are there more than two? No, there are two, but not 3, 4, 5, 6, or 7. Is the first atom, so we're talking calcium right now, is it a member of family 1 or 2? Yes, it is. So I come down. All right, pretty simple in this box. Name the first atom as an element and the second one ending in IDE. So I'm going to name the first one calcium and then the second one oxide. So I mean, that wasn't that awful, I hope. Calcium oxide. Do this all day long. All right, let's move down to BaSO4. Here we go. BaSO4 is what I'm looking at. Does it contain more than one? Yes. Is barium a metal? Yes, it is. Now, this is a yes this time. Look, are there more than two types of atoms? The answer is yes, because there's barium, sulfur, and oxygen. Is barium a member of family 1 or 2? Yes. Okay, so this is the same idea. It says name the first atom as an element. So we'll say barium. And then you name the polyatomic ion group. So we just put barium and then we find the name of SO4 is right here. So barium sulfate. Okay, not awful, I hope. Okay, here we go. HClO4. First off, let's look. Is hydrogen a metal? No. Okay, so remember that. It is not a metal. So here we go. It definitely has more than one. But here, does it have metal and non-metal? No. Does it start with NH4? No. Is the first atom a hydrogen? Yes. Name the acid. So we're looking for HClO4 right here. Yep, perchloric acid. All right. The next one is hard. Okay, so please, we'll do like 5 of these type. They're the hardest ones of all of them. Now, they're doable. Just follow the instructions, and we got to do a tiny bit of math, but please watch me do number 4 together. Number 4 is Cu, and I already forgot. C2H3. All right, so here we go. Definitely more than one. Copper is a metal. There's 1, 2, 3, 4 types, which is greater than 2. And then this time the answer to copper is no. Okay, so please, I said please enough times. If you'll repeat this with me over and over, it won't be hard. It's just tricky at first. So I'm going to put it right down here. Make it nice and fat so we can see it. It says well, I don't need to be that fat yet. First off, it says multiply the charge of the polyatomic by how many units there are. Okay, so what does that even mean? So this thing right here is the polyatomic ion, correct? How many acetates are there here? The little numbers are part of acetate. So there's just one. We okay with that? It's just one. If there was more than one, it would have been parenthesized and then like a 3. Does that make sense? Okay, so it's just one. So it says multiply the charge of the polyatomic by how many units there are. So we know there's one. So I'm going to put it right here. I'm going to put times 1. And I know timesing 1 is dumb, but it's, trust me. So the next thing I need to do is find the charge of the polyatomic ion. So acetate is a -1. All right, here we go. So I know it sounds kind of dumb. We're just multiplying ones and ones. So we multiply the charge of the polyatomic ion by how many units there are. So I end up with -1. Then it says divide the absolute value of this number by the number of first atoms. Don't panic. We take the absolute value and it makes -1 become a 1. And then I divide it by the number of copper atoms. How many are there? 1. So I end up with 1. That was a ton of math to get the number 1. Now trust me, oftentimes these are not just ones, so you have to do this process. What? Well, we took the absolute value of it to make it a positive. All right, so now just follow me here. Change this number to a Roman numeral. So I'm going to put a 1 right here that follows the name of the metal. copper 1, and then we write the polyatomic ion's name. This step right here is how we find the Roman numeral, which is the charge of the metal. I know it's tricky, but it's not awful. We take the charge of the polyatomic ion, multiply it by how many there are. We take the absolute value, divide it by the number of first atoms, and you get that. Okay, so copper 1 acetate. Let's find another one just like that. Right here. Number 9 takes us to the exact same box. So please work with me on number 9. So number 9 is CONO2 or 3 right here. 2, 2, correct?
Yeah.
Okay, same box, just follow along with me. It says multiply the charge of the polyatomic by how many of them there are. So I'm going to go find NO2, and it's going to be right here. So it's a -1. So I take -1 and I multiply it this time by 2 of them. That is a -2. I take the absolute value of this so that the answer ends up positive. That's the only reason I'm doing that, is to make it positive. And I divide it by the number of cobalts, which if there's not a number, it's a 1. So this equals 2, and that becomes a Roman numeral 2 that follows the word cobalt. Cobalt 2, and then the name of NO2 from the front was nitrite. Cobalt 2 nitrite. And it's official, all my friends. All 3 of my fantasy football teams lost yesterday in the first round. So, yep, that's my last update for all of you. I am a loser. I am pathetic. I am trash. Whatever you want to call me. I am a metal. It was a rough year. Let's just put it that way. All right, will you try number 23? Same box, try number 23. Yeah, whoever said Henry went off for them, some of us had to face Henry yesterday or this weekend. That was great. I just got my butt kicked. That's what I had. Okay, you're trying number 23. It's now a 3. Yes. Sweet. I will wait. It's just so depressing. They come in just, hey, your team was defeated. Hey, your team was defeated. No, you don't say try. You put a Roman numeral.
Oh, and then because of the Roman numeral, that's when you drop and swap.
Uh-huh.
Okay. When would you use those?
Just another one, just by the way. You'll use those if you end up over here.
Okay.
But since we went this way, we don't use prefixes. All right. Raise your hands if you have an answer.
Oh, yeah.
Okay, here we go. We end up over here again. I'm going to take the charge of acetate, which is -1, and I'm going to multiply it by that number. All right, that's the same thing we've been doing over here. That's -3. Then to make it a positive answer, I take the absolute value of it, and then I divide by the number of first atoms. Now, look, the number of first atoms is not always 1. It's just in this example it has been, or in these 3 examples it has been. All right, so we change this 3 to a Roman numeral. That comes after the name of the metal, which is iron, 3, and then acetate. We okay with that? All right. That's how we do this corner. Tori, hand me your lab book for a second. Yep. Let me find one where the first part is not just a 1. Okay, 11, 11 doesn't go to this box. 11 goes to this box. Yeah, because barium is a member of family 2. Okay, so there isn't one on this side. Hold on, here we go. Ooh, this one's rough. Try number 30. Almost everyone always gets number 30 incorrect. Is it Hg2SO4? Okay, this is number 30. This is one that's very commonly incorrect. Hg is mercury. All right, raise your hands if you have an answer. Okay. Just getting to the box. I told you it was the same box. It's okay. So are you there?
Yeah.
Okay, good. All right, O'Riordan. What's your Roman numeral? Nice. Does anyone have a different Roman numeral than a 1?
Whoa.
Okay.
It's 1, I have a 1. I didn't have time to do it.
You
but I have
guys,
a 1.
you guys must be smarter than the average. All right. Oftentimes, people get a 4 here. Did anyone get a 4? Thank you for being honest. Is that you, Odessa? All right. Now, honestly, probably half of you were on your way to a 4, but then I said it was a 1. So here's what we do. You have to remember, if there's not parentheses, there's only one of these things. So it's tempting. It looks like there's 4 of them, right? But there is only one sulfate, and its charge is a -2. So I take the charge, multiply it by how many there are. -2 times 1 equals -2. Absolute value, divide that by the number of first atoms, and that's where I got the 1. So I end up with mercury 1 sulfate. Now this Roman numeral, it is important that we have it when, well, hello.
You printed the wrong QR code.
Well, it doesn't work anymore anyway.
Okay, sounds good.
Jesse made a Zoom and sent it out. Ask him for QR codes.
Okay.
What QR thing did I send you? Okay, she's
Yeah,
gone.
she's gone.
That'd be funny if it was like my inbox to my email. I was like, whoa, Davidson. All right, look. Only this box, this box, this box, and this box need Roman numerals. Most of them will go here or here, and you don't. So let's look at number 11, because people will definitely think it needs a Roman numeral, but it does not. if you put one, then yeah, you should not. You would take it out. Yep. All right. So this is Ba3PO42. And this is how we would do that. We would come over here. But this question would say, is barium a part of family 2? And you'd say yes. Does this piece of instruction say anything about a Roman numeral? No. You may want to write a note to yourself. No Roman numeral, because kids get it wrong a lot. So we would just write the name of the metal, barium, phosphate. Yeah, these two boxes are a piece of cake. Okay, now I'm going to attempt to explain why, and it will make sense to some kids, and it will not make sense to others. But on the periodic table, wherever I put it, barium is right here. Barium is always a +2. Now, so to remember that, it's always a +2. If I go to this box and do this process, it was Ba3PO42, if I remember right. All right, I would have taken -3 times 2, that's a -6. I would have multiplied it by the char, or that was it, sorry. I would have taken the absolute value and divided it by the number of first atoms, and I would have got a 2. And then you would have thought, oh, I'll put barium 2 phosphate. But for the metals where the charge is always known, barium will always be a 2. I don't need to put a Roman numeral 2. These right here, you'll notice, they're not on here. They're in this area. They don't have a charge, so I have to state the charge. So I know it's tricky, but that's why one is Roman numeral and one is not. Okay, let's move to one we haven't done yet. Holy. Getting all sorts of texts. 64. 64. Oh my. Oh, look at it is 9:18. I'm going to be at the school today until 2 a.m. tomorrow. Can you imagine what I'm going to be like at midnight? I'm dead. Except to chaperone those losers in the box.
I thought Parker was doing that.
It's split up. He comes at 2 a.m.
Oh.
So I got school, then I got track, then I have to announce, and then I go and chaperone kids in a box. So that I can wake up and get here by 6:30 a.m. to act like everything's normal tomorrow morning. It might be time to drink. All right, I'm sorry. 64. Oh my gosh.
It's the hydrogen force throwing you off.
It is. Okay, let me try this again. 6 is the next problem we're going to do. I'm losing my mind. NH4OH. Here we go. These I like. Well, I don't really dislike any of them. More than one, right? Is N a metal? No. Is NH4 first? Yes. Write the name, ammonium, and then whatever comes after it. So look, it's NH4, and then OH is a polyatomic ion. So I would look on my polyatomic ion chart. Where is it? OH is right here. So I just write ammonium hydroxide. To me, the NH4s and any of them that start with the H, those are the easiest of them all. All right. Number 10 is a little tricky. 10's tricky. It requires a Roman numeral because titanium is not a metal with an assigned charge. So let's look at it. It takes you to this area, which isn't bad. Kids get annoyed sometimes, but whatever. I work through it with counseling. You can too. All right, so it's Ti3P4, is that right?
Yes.
Thank you. All right, so yes, yes, no. This time there's only two. All right, now, is the first atom, which is titanium, any of these? No. Now, my friends, this tricks kids every time. Notice it's underlined and in bold. The rest of these questions are talking about the second atom. All right? So, is the second atom a member of family 7? No. Is it a member of family 6? Is it a member of family 5? Yes. All right. So, this one is a lot like this top one. Multiply the number of the second atoms by 3. So there's 4 of them. Arrington, what time do you go to bed at night? Do you? You're just a sleeper? Okay. It's fine. I'm not offended. It's just like I'm worried about your neck. It's going to snap one of these days. All right. So there's 4 of these. I multiply it by 3, and that gives me a 12. Then I divide by the number of first atoms, which it'll seem pointless, but it doesn't always work that way. I divide it by 3 and I get 4. Use this as a Roman numeral to follow the name of the metal. So we have titanium 4 phosphide. I'm proud of you, my friend. Okay. All right, titanium 4 phosphide. Okay. Now this one bugs people because it just says multiply the number of second atoms by 1. And you're like, why would I need to do that? But it's just following. For family 5, it's 3. Family 6, it's 2. And family 7, it's 1. So just follow the instructions and you'll be okay. I promise. All right, let's find one we haven't done still. This one, number 12. Number 12 takes us to a completely different region as well. It was Pi3. Is that right? It was a 3. Okay. So, does it contain more than 1? Yeah, it has 2. Is phosphorus a metal? No. Does it start with NH4? No. Is the first atom hydrogen? No. Good heavens. Are there more than 1 of the first atoms? No. So we're finally here. This one says, name the first atom as an element. So that's just phosphorus. That's just phosphorus because I say it does. And then, carefully read this one. The second one ending in "ide," but make sure and do the rest. Include a prefix on the second atom to tell how many there are. So there are 3 iodines. So it is tri, and it's a weird one, triodide. Triodide. Triiodide is fine, but it's just triodide. Yeah, it's weird, but it's fine. Okay, now, everybody, look at me for a minute. Once I teach this box, all of a sudden, everything we learned before, you're just like, oh, I get it. This is lead triiodide. This is lead triacetate, lead tetrahydroxide. No. Only put the prefixes if you're in this box or this box. Prefixes, I know this might be confusing. Try and stick with me here. Prefixes are only used when we are naming covalent substances, which would be here and here. All right? We never use a prefix with an ionic substance, which is everything over here. All right, now you're like, well, what's an acid? An acid's an acid. It is covalent, but acids just have names. And then ammonium is actually an ionic compound, but we don't need to talk about it. Hey, who would have knew that makes black? I'm entertained suddenly.
What?
I know. Something shiny. I'm going to chase it. This is so fun. Okay. Let's find something Let's find another one like that. Oh, hey, can anyone do 17? What? Hit not now on there. Tetra. No, look right here. The prefixes are right here. Tetra's a 4. Anyone ever played Tetris?
See?
Every single shape in Tetris is made out of how many boxes? 4. So that's where that comes from. Tetra is 4. Oh, you're cool. Okay, we've done pretty much one from every box. This was just iodine, right? This one kids get wrong a lot. You want to try 20 without me? Try 20 and then we'll come back and look at it together. Yep, well, the other half, did you do all 50 of them? What a man. Then you can take a nap.
Good for you. Yeah, you can take a nap and dream about your swim.
All right, Jesse Roberts started a Zoom. Let me, well, shoot, what would I watch that on? Because I'm on Zoom. I have big oof. I will, this is what I can do, maybe. Ow. Did you just laugh at me, Bella?
I just get a lot of energy.
Okay, well, that's good because chemistry, don't tell anyone, is kind of boring. So I try and make it interesting. Good.
I like God Daddy, but his class, I almost passed out in every day. And I've never fallen asleep in class.
God
This one you're doing
Daddy.
better. I don't think I almost fallen asleep once.
Oh man, he's got to turn off the waiting room. What kind of amateur Zoom guy is this? Jesse Roberts, my second favorite person to talk trash on besides Peter Burt.
I like that. He was my driving instructor. He did cool things. I like
He was your driving instructor because your driver's ed teacher gave you to him.
Yeah, I appreciate that. We went to this place.
A Good Place, that's a show called about heaven. By the time I get this working, the bell's gonna ring. Like, how good has my technology been working for me today? Let's be realistic. Are you talking to me, Blake?
Yeah.
What'd you say? Oh, sweet. Do you have a pencil? I'll get one. Tin-4 oxide is correct. What did you get, Bella? What are the odds of that? That was quite the turn of events. Sorry. I know, that one was kind of on, it just barely skimmed my seat and then it disappeared. Okay, this has got to go away for a minute. Just trying something. All right, how are we doing? Oh, that shocked me bad. It is not my day. Yet. Thank you, Colin. All right, did we get tin-4? Tin-4 oxide. You what?
No, I said yes. I'm going to the box.
Oh, that's all right. So the instructions say, take the charge and multiply it by the number there are. -4, right? Divide by the number there is. Oh, this is a different area, isn't it?
Yeah.
Okay.
Yeah.
Well,
So,
say,
you mix it up.
it's,
You mix it up.
well, the answer is the same either way. So it says to take the number of these and multiply it by 2, divide it by the number of first ones, tin for oxide. Okay. The same deal applies. If you complete both columns and bring it tomorrow, I will show you